all black. I can't see it. Oh, yeah, I
It's
can.
fine.
All right, today we're going to be talking about combinatorial games and Nim. But first, we got to continue the two-thirds games. So if you remember the rules, I just like recopy pasted them. Everybody picks a number from 1 to 100, and the person who is closest to two-thirds the average is the winner. So I put the link in chat a little bit
I
earlier.
bet you like some people like gave up on the game, and then just like started going to trolling.
Maybe.
Hey, we can edit our responses. So I can just put 12 there and I win.
Oh, yes.
Yes!
This is round 4. Even though it says two-thirds number game 3, it's the third, what is it? It's the third online version. But the round 1 was from the in-person, or not the Zoom chat version that we did a while ago, right?
So this is round 4, right?
Yeah, so this is round 4. So I didn't really give you. You can also edit your responses. If you want to change your number, you can start editing your responses right now based on what you think everybody else is going to submit. And like, oh, are people going to be trolling this round? We had a couple of trollers in round 3, so maybe people are going to troll a lot this round. Or maybe there's going to be no trolls because people are completely logical human beings. They act as if being human.
So what trolling did they do?
I don't know. What trolling did they do? Oh, by trolling, I mean like submitting 100, basically, right? There's just somebody submitted like 0.8973, something. You can submit 100, right? I don't understand why somebody's like, oh, I can game the system if I submit 99.9999999 because you can literally submit 100. So, anyways, I'm currently
0.999.9 repeated.
I'm currently just stalling a little bit, to be honest, because oops, my computer's trying to get back on. But oh, I gotta go check out the responses.
Go on.
Oh, has everybody submitted who wants to submit? Oh, that's the new game that we're going to cover in a little bit.
Wait, did anyone submit more crazier than before?
What?
Did anyone submit crazier than before?
I know. That's for the game to figure out when it actually starts up. Oh my god.
Wait, are there any numbers you're gonna have trouble like multiplying out?
What?
Wait, are there gonna be numbers that you have trouble like adding?
What do you mean? No, it's not. I have the spreadsheet to automatically add it, right? So it's not really any problem to add stuff. So if you want to like resubmit some really bad decimal you think that would be hard to add, I don't have to add it. The computer adds it for me. So
maybe I could just log into a new account and do something else.
All right.
Who won?
Wait, did someone just submit something?
You might have noticed that my account just went into disconnected audio and then reconnected. And that was because I just
Found your middle name.
joined.
You were lying the entire time.
Oh no! All right. Has everybody submitted if they want to submit? I'm not seeing any response. Okay, my Google form is lagging right now.
Maybe because the
You
sheer
were
amount of numbers.
lying about your middle name and last name.
Oh, wait, my middle name isn't whatever it was. All right. Okay, so we have some pretty pro submissions. We have some
what?
pro edited values. And ooh, okay. So now I'm going to announce the winner. Okay.
I bet
So
you this is gonna be like a crazy number once like the actual number.
This time the average was 32.3.
Oh, that's not the actual number.
32.3. Even though I like how the round 1, round 2, round 3 averages have all just been going down, right? And then suddenly we have 32.3 because we have an increase in the amount of strollers. And if we look at the average, it makes our 2/3 the average 21.5.
I'm gonna post it right now.
20. Oh, if you edit it right now, then it's not going to be able to count it.
Oh.
21.5. Therefore,
Good one.
2/3 the average. The person closest to 2/3 the average is, oh my God. All of these numbers are just not close to 21.5 because nobody's expected it. So
Me.
our winning number was 15. Woo.
Oh.
Submitted by Sussy Man. Very cool name. So good job to Sussy Man for guessing 15, where the average
I
was
guessed
21.5.
8.
Rip 8. Oh my God, is my computer not working? Okay. The computer is still continuing to work. Okay. So it's kind of like round 1, round 2, round 3, we're seeing some like consistent decreases. However, by round 3, we're not like decreasing as much as we did between rounds 1 and 2, right? We're just
Wait,
kind
next
of
time,
like,
everyone just choose 100.
that'd be pretty funny. But then somebody could like game the system. If everybody chooses 100 and you choose 66, right? 67.
But then you could do 66.1.
Oh no, 66.66666. Okay. So now I want to play a different game, which is going to be, let's pretend that we have a set of coins and like with just a pile of coins, we have like a whole bunch of pennies on the side there. You can either take 1, 2, or 3 coins. And the person who takes the last penny or coin wins. So let's play this game in Zoom chat. So does anybody want to 1v1 me in this game? Definitely. There will be ways for you to win, but you'll have to figure it out just by playing against me. So anybody wants to play this game against me?
So you just choose 1, 2, 3?
No, so essentially we start with like a certain pile amount of coins, right? So let's say we initially have a pile of, I don't know, 21 coins. Then the person, we alternate turns.
Oh, you go first then.
And we alternate turns and we can either take 1, 2, or 3 coins. So I can take like 2 coins and then go down to 19, and you can take like 1 coin and go down to 18, so on and so forth. And that's how the game is played essentially.
Then you go all the way to 0?
All right, looks like
Can I go against? Can I try?
Apollo wants to 1v1 me. So, all right. Give me what number of coins should we play with, and who should go first? Just give me some numbers.
You should go first. And wait, you want me to give you a number of coins we're gonna?
Yeah, like that's not like more
4.
than 10.
Do 4, 4, 4.
Wait, more than 10?
Yeah,
Can't be more than 10.
It
You have
has
to put
to,
like a decimal.
it has to be more than 10, and it has to be like a whole number. It can't just be like
More than
it doesn't-
10?
Yeah, it has to be more than 10. 100 would be a little bit large. It would take a while to play, so probably somewhere between I don't know, 10 and 30, I'd say.
Oh, okay.
So that actually ends. So okay, so do you want me to go first, or do you want you to go first, or do you want to go first?
You can go first.
All right, so from 30, I will bring it down to 28 by taking 2 coins. How many coins are you going to take?
Take 2 coins.
All right.
Take
Instead
2
of like,
coins.
Paula, you're like DMing me, so I prefer if like it went to everybody. So Paula submitted 27 by taking 1 coin. I think I will take 3 coins and then go down to 24.
Ooh, I think I know who's going to win.
Okay, 23. Okay, we can go to 20 coins. I'll take 3 coins. 19. Okay. I will take 3
think you know
coins. So
my
it goes down to
strat already.
16. Remember, the person who takes the last coin wins. So, all right, I will take down 3 coins from that. So now it's back at 12.
Take 3.
All right, 3 was taken, so it's now 8, 9. So I will take 1 coin, and now it's at 8.
-3.
Okay, you took 2 coins, now
Ah.
it's at 6. So how would I take 2 coins also, and now it's at 4? Uh-oh. Looks like you're kind of in a pickle. I take 1
I
coin?
told him to take. I told him to take 3 in first place, but you took 2.
Okay. Row, kind of that's 4. So you take 1 coin, and I take 3 coins, and all right, it's at 1. I'll take the last coin.
7
and
wins.
Yay! All right, very cool. Anybody want to also 1v1 me?
Can I go against you?
Can I go?
I don't know who I is, so like just
Okay,
like DM.
Grace, me.
Athena?
Okay, Grace, how many coins and how many?
30 coins.
Okay,
start.
Rebecca.
You should pick like 10 for the least. It goes so fast. I mean, it's like easier to predict. You can go first.
Okay, if I go first, I'm gonna take 2. 28. You can go now.
You should never let him go first. Lesson learned.
26. 24. Let's go.
You already know you're gonna win at this
We're
point.
gonna take 2. So we're at 20
Oh,
now.
I get it now.
All right, you choose 18. So how about I just go down to 16? This is you
You
take 2.
want
I
to choose
take 2.
only even numbers.
I mean,
Yeah, I remember
guess
this game.
that's just how we're playing it. But all right, now we're at 8. Oh, we're at 4 now. What do we do? Yikers.
4 is like the best thing to get. You should absolutely avoid 4 ever unless you're trying to get
Okay.
4.
I take the last 2 and I took the last one, so I win. Woo. Okay, does anybody else want to 1v1
Can I
me?
go?
Okay, sure. All right, pick how many coins and pick who goes first.
10!
10.
And then you go first. Wait, Athena's
Wait,
go first.
Athena, yeah.
I want to go.
Okay, Athena, how many do you want?
10.
And who should go first? Oh, you're going down to 8 immediately. Okay, so how about I go down to 7?
When I smile, you know you made a mistake already. Subtract 3. No, you should.
Okay.
I made a
Pretty sure that a
mistake.
lot of you guys figured out that Athena could have won there by going 4, but
Oh, I
um,
accidentally made a
You
mistake.
could have made 3. No. You had the
Okay.
opportunity. No.
I think that I'm gonna officially ban 10 for being too low of a number. So we're gonna go up to 15 being the minimum number.
Wait, can you make something more maximum, like 100 maybe? You know?
Just would take
then make it so you can
ages.
Oh,
take, like,
I want to rematch.
25
I want to
points.
rematch.
And then you could like
Oh.
just subtract 25.
Can I
Oh,
go
we can-
again?
Oh, we can play 100 coins and we can
I
subtract a
go
maximum of
then?
25.
Can I go
Oh,
again?
I kind of want to see if there's anybody else who like isn't. Okay, Caleb, how many do you
Pick
want?
11.
And it has to be greater
Kevin
than
goes
50.
first.
Has to be greater than 50. Okay, 20.
16.
So do you want to go first or should I go first?
Even numbers always go
Okay.
first.
You just made a
I
mistake.
will
Don't
go
never let him go
to-
first.
I'm going to take 1, so
Even
19.
numbers, you always go first.
18. All right, so I'm going to go down to 16 now.
12.
So taking 2 coins. Take
No.
3 coins. So I'm going to take 1 coin and go down to 12.
Take 2. Go to 10. Take 1.
Uh-oh,
Yes.
you took 1 coin and now you're at
You
11.
take
So
2?
I'm going to take 3 coins and now we're down to 8.
Uh-oh.
Uh-oh.
Go to 2. Do 2.
All right. Has
It's
Vin's
seven.
already won.
anybody
no.
figured out? Has anybody figured out the strategy that I'm using?
I know the strategy. I know the strategy.
I know the strategy now.
You have to go first, though.
I mean,
Every even number, you go first. Every odd
Okay.
number, Every even number you
No, you have to.
All right.
I know the strategy. I just played this a few days ago.
Can I play?
Right?
I know the thing. Oh.
Okay, I can beat you if I go first, Grace.
Can I go?
But I have to choose the amount of coins.
Can I go?
I'll go for 30, and you go, and I'll go first this time.
Okay, so go for 30.
Yeah.
Okay.
That's risky.
So who's going first? Oh, you're going first, right?
Yeah, I'll go first.
Okay, 28. Let's go down to 27. I don't like taking too much. Dun, 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 dun. 26. Oh, interesting. We're going to go to 24 then, taking 2 points.
You just said you didn't like going down 2 coins.
Well, what if I wanted to go down 2 there? I want to go down 2. We can go down to 16.
Oh no, I already see what's coming.
You go to 12. Ruh-roh.
Uh-oh. No.
It's down to 8.
You need 9.
Okay, so I think there's a next. Okay. We're going to go back to that in a little bit. I mean, you can play this over and over again until somebody beats me. But
Kevin knows all the tricks. That's not fair. Like, I should make a game where I'm in an advantage and Kevin just loses every single time.
it's not fair. I'm literally allowing you to pick who goes first and allowing you to pick what number of
Like,
coins
if your
we
name
really
starts with a
have.
K, then you must, like, lose immediately.
All right, so I'm going on the 4. All right. Oh no, I took the last coin because that's 0.
9. You have
Can
to
we do
like,
a
do it in
rematch?
multiples of 4, don't you? You have to like take the coins. If you do 1, then I have to do 3.
Can we do a rematch?
Ah.
Okay, does anybody think they have a winning strategy?
I knew it was a strategy.
Make Kevin do things
Wait,
for you. Like,
Can I go?
Sure, I guess. How many Bitcoins? And
16.
15.
15, who goes first?
You.
Okay, I'm going first at 15. I'm going to take 3
I'm
coins.
testing. 3. 9.
Maybe you take.
Okay, you take 1. I'm going to take. Wait, you take 3. So I'm going to take 1. So it's down to 8. Clan takes too much. Uh-oh. I like how you guys feel like 8 and you're like, oh no, it's already over.
Can I try?
Sure.
I want to try one more time. I made a mistake.
I haven't tried. You've tried like 2 or 3 times. I've tried once. Okay, let me try. I'll go first. And we're going to, wait, what's the limit?
30.
We're going to 30.
Okay, who goes first?
Me.
Okay, what you gonna do? $29. Okay, I'm gonna go to 28 then. Could only take 1.
Go 25.
Okay, 25. How about I just go
He
24?
does 24.
Yeah, 24 is a fun number. I like
You
24.
3.
All right, you say 20, I say 21, I say 20. I can take 1 coin. Yeah, this is like. All right, 16. Let's go. Okay, you say 15, I say 12.
Uh-oh.
Uh-oh.
10.
I think I can.
I already gave up.
Okay. Oh, I see that some of you guys are submitting links to some of the answers. I think this should be an answer. I don't know.
Wait, is the strategy like to
Can I
get
go
a
one more
multiple of
time?
to get a multiple of 4? For example, if you do 1, I have to do 3. If you do
If you-
2, I have to do 2.
If you think you have a winning strategy, then feel free to try it against me. You know, are you confident with your winning
I think.
strategy?
Wait. Can you win after I put 5 since you put 8?
Oh, sorry, 4.
Why?
Can I try?
Yep, just put you in.
Okay. Grace, you have a winning strategy?
Guys, just type in
Can I-
YouTube videos how to beat Kevin in every single game.
Okay, Caleb, you can try. I'm just like sitting here, Jim the Game Master. I will win all of your games until one of you guys figures it out. All right, we can start at 21. Who goes first? Oh, are you guys watching the videos? Okay.
Absolutely.
Uh-oh. We're at 20, so I'm gonna go 19. This is it can't take too much. 16. Okay. How will we go down to 14? Oh, we're at 12
Oh,
now.
no.
Oh no.
No.
We're going down to 11.
Ruh-roh.
8. Oh no, I'm going to lose this. Oh no, we're going to 7. Uh-oh, I'm okay. Okay, looks like you beat me. Good job. Okay, so it looks like you found the winning strategy.
YouTube is the saviors.
YouTube is very OP. So if you noticed, the winning strategy is always just to go to a multiple of 4 whenever you can, because we can also always decrease it by 4 every single time, right? And the whole
Okay, let's play now.
all right, you already figured out how to win, so
Let's
you can
play.
now literally beat me every single time. Like I've been beating you every single time.
Yes, so it's time for revenge, payback.
Can we start
I
at...
certainly won't let myself put up to that kind of humiliation, right?
Let's start at 21.
Okay.
Already
I
dead.
go first.
I knew
So-
it was the multiple of 4 thing. I just couldn't execute it properly.
Okay. So essentially, the whole idea behind this is that there are things called P positions and things called N positions. And the definition of a P position is that the previous player has a winning strategy and the N position is the next player has a winning strategy. So like, you might be wondering, how does this work with everything? So if you think about how this game played out, every single time a player said 16, right? They left their opponent with 16 coins. Then their opponent has to make a move from that 16, right? Therefore, we would say that 16 is a P position because the previous player had a winning strategy, which is to send it to always to a multiple 4. And in general, we can say all multiples of 4 are P positions. But like, how do we figure out what an N position is? How do we know exactly how these work, right? So to figure this out, we have to look at the definition of a P and an N, the definition of these coins. So just as like sort of an introduction, when there is 1 coin left, is it a P position or an N position? Essentially, if there's 1 coin left, yeah, exactly. Because if there's 1 coin left, the next player to go literally just takes the 1 coin and then wins, right? How about 2 coins? Is it P or an N position?
And
Yep. How about 3 coins? Yeah.
And
Yep, all of these are in positions because we can say that the next player has a winning strategy, which is simply just taking all the coins. It's pretty simple, right? All right, how about a tricky one? How about 4?
P.
and
Okay, so some of you guys think
wait,
P is...
P.
Yeah,
Wait a sec.
you guys got really used to saying N over and over again. But 4, like no matter what, whenever I said 4, you guys are always like, oh no, he's gonna win because 4.
Ruh-roh.
So 4, that is a P position, right? Because you don't want to be in that position. You want to send your opponents to that position. How about 0? Any thoughts on having 0 coins left?
P.
P.
Yeah. And the logic there is that if there's 0 coins left, then the previous player must have taken the last coin. Therefore, the previous player has a winning strategy from 0. So essentially, based on these ideas, we can figure out what type of positions are So first, to figure out how to like solve this game, we need to figure out what is the position of the ending position. In this case, you could say that having no coins left is the ending position, and we say that that is going to be, say, I don't know, we start at a end position, right? Okay, somebody asked me if there's going to be another game. Sadly, there won't be unless we like move through these next slides really quickly, and even after that,
It's just a 2/3 game anyway.
We will.
Like, people can't wait to troll.
I don't think that I'm gonna like do the 2/3 game because the next time we're gonna do the 2/3 game
Trolls,
in class.
the people who troll never win.
Yeah, that's it. I mean, that's true, but like
They don't
also,
care. It's like
trolling
there's
is
basically. I mean, it's kind of. It's like. I mean, it's like you're not gonna win most of the time. So
I'm gonna-
like just troll it.
I'm going to set up a point system next time. So next, if you look at the schedule, you'll note that next week is just playing games. And I think what I'm going to do is I'm going to set up like a total point system based on how well people do in each separate game. And so people will be motivated, and the winner of the person gets like, I don't know, gets brownie points, I guess. There's nothing really I can do from here.
I hate those. Those are useless. My ski teacher used to use them.
If you want to be really competitive, then you can get all of the brownie points.
All scams. Don't try.
Your payoff will be 0. Using your game theory, your payoff will be 0 unless you like feel really good about getting all those brownie points, in which case it's a lot of points. Okay. So
The teacher have to give you money if you do brownie points. And ice
how would I even do that? Okay, so essentially, if all possible moves go to an N position, then what you have is a P position. So the idea of that is, if you remember 4, right? We said that 1, 2, and 3, all of those were N positions. That's what we said, right? And from 4, you can either take 1 coin, in which case you have 3 coins left, which is an N position. You can take 2 coins, which you have 2 coins left, and you can take 3 coins, in which case you have 1 coin left. All of those are N positions. Therefore, if all moves from a current like state go to a N position, then that position is a P position. Otherwise, it is an N position. Or in other words, if any one of those moves can move into a P position, then you have an N position. So from 1, we said that 0, that was a P position, right? So from 1, since you can take 1 coin from 1 and make it to 0, which we said was a P position, then that is a, That is a N position. And the way you can think about that is if you look at this graph on the right-hand side, right? You can see this graph here. So essentially, if you draw a graph, then you can write out like all of these endpoints are P positions, right? Because that's how we're defining the game. And then essentially, if you see like the 2 things that like go directly into the P positions, which are the like 2 things that are like kind of adjacent to it, we can say those are N positions because they go into at least 1 P position. But if you notice, we have that P position up like on the right there. And that's because we know that that has to only goes to N position. So that's like kind of how you can think about P and N positions, right? So I'd also like to make a note about, I said I skipped a slide, but this section of game theory is like pretty different from what we've been doing before, right? What we've been doing before, it's like there is like based on payoffs, right? And it's not necessarily looking for a winner and a loser. We are just looking at how well people will do over time, right? However, this idea of game theory is like much different because now in this idea of game theory, or what we've been doing so far, we're talking about games still, right? But we're still talking about games. However, it's not like, oh, we're trying to like work together or we could possibly not work together, right? In these types of games, there's going to be a winner and there's going to be a loser. So this is a specific topic in game theory known as combinatorial game theory. So it's like, if you think about chess, chess is a combinatorial game. And if you want more specifics about it, then you can feel free to ask me. But otherwise, there is a cool book. If you like combinatorial game theory, then you can look at the the cool book called Winning Ways for All Your Mathematical Plays. It gets a little bit dense in mathematical notation in a little bit, but
I don't know how you'd figure out like the game of chess. That's like so hard.
I mean,
like trying to figure out the possibility.
you could draw out like one of these trees in the bottom right corner, right? You can draw out one of these trees, and then you can like, I don't know. You can draw out one of these trees, and from these trees, you can, what is it? Oh my God, I'm trying to think about it. You can figure out that all of the losing positions, all of the winning positions, you can figure out which ones are P and N positions, and you just start going backwards and backwards and backwards. Except there's a lot of ending positions, and there's a lot of different ways the game can play out. And there's
Exactly, that's why it's so hard.
Ways. Yeah, it makes chess really, really, really hard to calculate out, right? There's a lot of different ways to play chess.
Now, can you post the slides in the chat?
I believe there is still one other thing. I don't remember if there's still one other thing, actually.
Is there?
I don't know. I gotta go check the slideshow. But I'm afraid the slideshow is going to crash my computer. So I will definitely post at the end of class, though. So let's think about like why this works, right? So if all possible moves that you can make from any given position go to if all possible moves go to an N position, then we say that there's a P position. But why does this work? So if you think about it, if all the possible moves that you can make force you to an N position, right? That means that you are forced to move to a state where the next player, by the definition of N position, there will be a winning strategy for the next player, right? So imagine you are player 1 and you are sitting in a place where there's only N positions, right? You pass it on to player 2 and you move player 2 to an N position, right? Therefore, player 2 is going to have a winning strategy. So if from no matter what, okay, so the way that P and N position like notation works is that you just think of it as previous and next. So P position means that the previous player is going to win, and N position means that the next player is going to win. That's where the names come from, right? So an N position means that you want to be the person that's going in that like position, right? So, and it was in the previous thing, it was 1. You wanted to be the player who was in 1, right? You wanted to be the player who was moving from 1 because then you would be able to take all of the, You would be able to take all of the objects or stuff remaining in a pile. Oh, we do have a game later on, right? Okay. So I can't share the slides. I just remembered what it was. So that is a P position. Okay. So essentially, if you are forced to move to an N position from a given place, right? So that'd be like 4. You are forced to move to either 1, 2, or 3. So you don't want to be, it means that by definition, by passing the opponent's turn to an N position on next turn, it means that by definition of N position, they have a way to win from that N position. So that is where we get the first definition, is that if all possible moves go to an N position, then you have a P position. And if any one of those moves go to a P position, then if you can send your opponent to that P position, right? If you send an opponent to the P position, then by the definition of the P position, you will have found a winning strategy because from the P position, the opponent is forced to lose, right? I don't know. You can think of P and N positions as winning positions and losing positions, right? So you want to send your opponent to a losing position. So that means that if you can send from any position, you can send them to a losing position. That position must be a winning position. And if from a certain position, you must send your opponent to a winning position, that position must be a losing position. That is essentially what these two rules mean.
What's the next game?
We'll be going over that in a little bit. Essentially, the winning strategy is to send your opponent repeatedly into a P position, which is kind of like what I was doing. I was repeatedly making you go to 4. I was repeatedly making you take something from 8. I was repeatedly making you take something from 12, so on and so forth, right? So that is the winning strategy, right? Also, I'd just like to make a note. I'm only going to briefly go over this, but I said that in the definition, we like to figure out exactly like how to win a game, we need to figure out what type of position the ending position is. So in combinatorial games, there are two different types of games. One is known as normal play, and the other is misère play. So in normal play, the last person who can make a legal move is the winner, right? So in the pennies game that we played from before, the last person who could take a penny was the winner. The person who, or in other words, the first person who couldn't make a move is the loser, right? Because once I take all of the pennies, you cannot make a legal move. Therefore, that is normal play. However, misère play is kind of the opposite. You are trying to run out of moves. You can think like, I don't know. You're trying to hurt yourself. But in misère play, the first person who cannot make a move wins. You're trying to run yourself out of moves. And that changes whether the zero position or like having nothing or no players can make a move is a P or an N position, right? Because if you're trying to make the first person who cannot make a move, if there's nothing that either player can do, then that would be in N position, right?
N position.
N position, P position, okay. Moving on. All right, so this is the game that we played before, right? The pennies game. And I've just like sort of put out the, what is it? The letters or the numbers. I was hoping that I'd be able to write on the screen for this, but it looks like I can't. So
I see a pattern. The first one's all even, the second one's all odd, the third one's all even, the fourth one is all odd.
I mean, not like row base, but like mostly put in the P's and the N's. So
and it's +4 for the last one.
Is
plus
0
4 for the first one, +4 for all of them.
Okay, so is 0 a P position or an N position? We covered this in
Wait, 9 is 4, I mean.
So in a P position, you are like losing, or the previous player to play has a winning strategy. And N position is where the next player to go. Okay, somebody said P position, and yep, that is right. So 0 is a P position. How about 1? Is 1 a P position or an N position? We already did this like a while ago. Okay, so 1 is an N position. I'll just like fill these in because we sort of did this before. You can sort of do this whole idea over and over again. 3 is an N, and you'll find that 4 is a P position. And as you go through this, you'll realize that every 4 positions is going to be a P position, and that's just based on the design of this game. Therefore, we can say that this like repeats infinitely. So we know that the strategy, no matter how many like pennies we have or how many coins we have, is always to force your opponent to make a move from like 4 pennies left, or 8 pennies left, or 16 pennies left, or 12 pennies left, right? And this gives us like a powerful way to figure out exactly how to figure out these games. Okay. We could have hypothetically played this game with 100 pennies, but then the game would have lasted forever, which I didn't want to happen. I wanted them to be short, but not too short, right? It would have been kind of bad for us to start at 1 penny and be like, okay, we're going to start at 1 penny and I'm going to go first. Oh, I took the last penny. I win. It's kind of not interesting, but okay.
That's
Next,
very funny.
I want to talk about the second game, which is the previous game was very like a Nim-like game. So Nim-like games are just where you take numbers of objects, whereas just where you take objects from piles. This is like full game of Nim, in which case there are many piles with objects, and each turn you can take as many objects as you want from one pile. And the person who takes the last object wins or loses, depending on misère play or normal play.
This is basically like the same thing.
Let's just play this, what is it? Let's just play this normal play. So the person who takes the, oh, you think this is the same thing? Do you want to 1v1 me in this?
Yes, absolutely.
The person who takes the last object wins.
Also, if you want to 1v1 the computer 1v1 computer plays with misère play styles. So if you want to 1v1 the computer, you can feel free to do that. All right. So
I just know it's not the same thing. You wouldn't do this again.
Oh, it is the same thing.
Let's start with essentially how this works is that you can take as many piles or as many objects as you want from one pile. So if you remember before, previously I said that you can only take, what is it? That you can only take 1 to 3 coins, right? So you can only take, I don't know, from 7 you can only take.
The person who takes the last object wins. So what you could do 6. So then I go first, so you go 6, and then you win.
Okay, does anybody want to win me in this game?
Yes, me. I want
Okay.
to.
Do you want to go first or second? So I just want you to understand the rules pretty clearly, because the rules are a little bit confusing if you like first thinking about it.
I'll go first.
So the reason that you can't just take everything on the first turn is because you can only take objects from exactly one pile. So you can only take objects from, I don't know, the pile of 7, right? You can take 7 objects from that, but then you wouldn't be able to take anything else because everything else is in a separate pile. Okay, did you want to go first, Apollo?
Yeah.
Okay, what are you going to do now?
Wait, so how many piles are there?
There are 4 piles. One is just 1 coin, one is 3 coins, one is 5 coins, and one is 7 coins.
I'll take 1 from 5 coins.
1 from 5 coins, so that would be 1, 3, 4, 7 is what you're moving it to.
Yes.
I have to do a little bit of math. All right, let's go to 3. I'm going to take 1 from the first pile, so essentially that becomes 0, right? So 3, 4, 7.
I'm pretty sure I already made a mistake on my first move.
Your mistake was challenging me. Confidence. Okay. All right. So what are you going to do now? 2, 3, 7. Okay, gotta figure that out. I'm going to go to.
You should not be able to do math. That's cheating.
Let's go to 2, 3, 1. So if you remember, the person who takes the last object will win. Oh no, I guess I just have to memorize all this kind of stuff. All right, I'm going to take all of the objects from the pile 3, so it's 1, 0, 1. Uh-oh, uh-oh. I take something, you take something from one pile, I take the last thing from the other. Uh-oh.
Now
I will take an air particle from group 0 from the second group.
Great job.
Yes. Take something.
Yeah, it's definitely good
Then we
negative.
can just take 1 and then you take 1, so you win.
Zero.
Great.
Okay, does anybody else want to 1v1 me?
That's your 300
Can I-
IQ move when you're desperate.
Can I?
Sure, do you want to go first or second?
Second.
First.
First. Oh, I know.
Do you want to go first?
You
Yeah.
already made a mistake.
Wait, do you want to go first or second?
First. I want to go first.
All right, what are you going to do then?
Oh no.
Take 1 from the first pile.
All right, if you're going to take 1 from the first pile, then I'm going to take 1 from the pile with 5 in it.
Oh no.
This already looks very similar to the last game. Maybe I should have done something different
Take
this time.
4 for the
All right, if you take 4 from that pile, then I'm going to take 4 from, 4 from which pile?
the third pile.
The
I mean,
third
like
pile.
the 0307.
Okay, if you do this, then I'm going to take 4 from the last pile. 0303.
I take 1 from the second pile.
Okay, then I'm going to take 1 from the fourth pile. So it's 0202. This would be more fun
Already
to play in person. Okay, it looks like just like some sort of winning strategy here where some of the things make sense, but then there's also.
Oh, I think I know now. I think I know the strategy.
Okay. Does anybody think they know the
You
strategy?
want to be
now?
on the odd number.
I mean, the total has to be odd, or I don't know.
I don't know. The whole number has to be odd. For the next? Wait, I think.
Wait,
Yeah,
wait,
for the-
subtract 1 from 2 or something.
Then he'll do it and I'll lose.
And then it'll be 0101. Roll.
Yeah, this is impossible.
0101, then she takes one. Oh yeah, different.
For those of you guys who are just like sitting there and watching, you can 1v1 a computer online, and they will also beat you most of the time unless you figure out the winning strategy. There is a winning strategy for this. So, all right. So, does anybody want to go again, or does anybody want to?
Let me try.
I'll go again. I'll go again.
I'll go again.
I want to go again.
I want to go again.
You squint.
All right. So I'll just have Apollo go first because he was the one who went first the least recently. But if anybody else wants to try, feel free to like put in chat.
Okay, so I'm gonna go second.
Okay, you're gonna go second. I'm gonna take one from the pile of 7. So 1, 1, 3, 5, 6. One, 2, 5.
Ooh.
Oh, you DM'd that to me, so 1, 2, 5, 6. Oh, you already beat it. That's very cool. Okay, how about we take? Let's take 2 from 6. Wait, no, that seems not very complicated. How about we take 3 from, or 2 from, what is it? 2 from
Are you
5?
purposely making this complicated for me?
Oh, oops, that was in DMs. So, 1 second. So, Apollo responded with 1, 2, 5, 6, and now it's at 1, 2, 3, 6. Okay, looks like you figured out a winning strategy. So you can try 1v1ing me. Have you played this game before? Oh, okay. Looks like the computer is just being dumb. Okay. You're not dumb. You're being good at the game. Okay. 1, 2, 3, 6. What you gonna do? Okay, 0 to. Okay, so 0 to.
I'm doing math. I ban you for doing your
3,
math.
6. Can't ban me from doing math. That's like banning me from drinking water. Math is just
It's not the
something
same thing.
Okay, 0, 2, 3, 1.
Uh-oh.
Oh, I get it now.
Uh-oh.
Take 3 from one pile. And then I think you will win. Take 3 from one pile.
Well then.
Do it. Do
Okay.
it. Yes. You messed up.
Whoever suggested that, I'm not happy with.
Yes.
Okay. Does
Let me
anybody want-
redo that. Let me redo that.
Fine.
Okay.
Do
I'm
1,
doing-
1, 1, 1. It's better.
What do you Okay, Apollo.
Can I
So,
go?
My turn.
Athena
My
wanted to
turn.
go. Let me think. But does anybody else want to challenge me, or are you focused on the
You
online
go
version?
first.
Huh? Do you want me to go first?
Yes.
Okay, 1, 3, 5. Let's go down to.
See if you can survive without doing math.
Let's go down to 5. 1, 3, 5, 5.
Then take 5 away from the.
3, 5, 5.
So 3, 5, 5. 0, 3.
Wait. Can I redo that? 1 sec.
Sure.
1, 2, 5, 5. Wait. 1. Wait. 1, 2, 4.
1, 2. What is it? What do you want?
4, 5.
Well, you can't do 1, 2, 4, 5 because then you'd be taking 2 things from 2 piles, or 1 thing from 2 piles, right?
I mean 1, 3, 4, 5.
1, 1, 3, 4, 5. Okay, so let's go 1, 0.
Next time you say anyone want a 1v1 me, instead of the smiley face, you should make an evil smiley face.
1, 0, 4, 5.
Oh, let me think. 1, 0, 2, 5.
2, 5. 1023. Row.
Oh no.
I think you may have figured out the 1023 is a losing position, but shh.
Thanks for the clue. Everyone, the losing position is 1023.
Okay, we're already at 801, which just means we're all running late.
102.
102. We're gonna go 101 and
Oh no.
okay.
Game over.
Yeah.
So we don't really have too much time to cover this, but essentially the way that you have to win this game is that you have to convert all the numbers to binary. And
10101010100
That's computer
Okay.
stuff.
I mean, this is like computer stuff, but this also is fun math. I really bitwise XOR is like
Zero
one of my
one zero
favorite
one
I
functions.
like
zero
converting to
one.
binary.
So it
It takes a long time.
doesn't take too
I
long to
don't
convert to
like
binary.
that.
Nuh-uh, not
The way
really.
that
It takes an hour.
So the way that you, so I first want to explain binary works. So essentially in the binary system, we have like 10 digits, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But binary is essentially the same thing.
Is 20 a decimal? 20.00 is a decimal.
I mean, it's like what is used to describe being able to go from 0 to 9. So essentially the way that binary works is that we have 2 digits instead of 9. So I don't know, watch, if you want like a more in-depth explanation of binary, I need to like pull up the video, but
Wait, so after 4 minutes of that video, there's the rest of the video's an ad?
yes, after, I mean,
It's a scam of making you watch it.
it's a 5-minute video, but a whole like minute or so is an ad. So
Like watching like a 4-minute video and the rest 6 of it is just blank because he had to make the video longer.
So essentially how binary works is that you convert things into a string of ones and zeros, right? And I'm just gonna quickly go over to bitwise XOR because it's probably the new thing for a lot of you guys. And it's much easier to explain with an example. So essentially, if you have 2 numbers and you take their bitwise XOR, essentially, if the 2 numbers are the same, then the resultant number, or if the 2 bits are the same, then the resultant number is going to be 0. Not same means there's a 1. So in the example, we have 1, 0, 1, 1, 1, 0, 0, 0, 1, 0, 1. And the other number is 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, right? So the way that bitwise XORs that, we look at the first 2 numbers, right? One of them is a 1, the other one is a 1. So then we can say that the first number is 0. Then we look at 0 and 1. Those are different numbers, therefore it's 1. And then we continue that. So 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0. Right? And if you look at those 2 numbers, right? If the above 2 numbers are 1, then we have a 0 below. If there's a 0 and a 1, then there's a 1 below. We have a 1 and a 0, that's a 1 below, right? If they're different, then we have a 1. And if they're the same, we have a 0. So essentially, all I'm doing is I'm sending you to, what is it? All the positions that have a bitwise XOR of 0, 0, 0, 0, 0, or whatever, right? So if you look at all the like numbers that I've been sending, where I've been like winning. So one of them I've been sending you guys is 1, 2, 3, 1. You look at the binary of that, you see that's 1, 0, 1, 1, 0, 1. And the bitwise XOR of all of those put together is just going to be 0, 0. That's why I've been sending you guys to that, because that is a losing position or a P position, right? It might seem a bit weird to think about it like that, but there wasn't really anything too complicated that I've been sending you to. So 3, 4, 7, right? 3, 4, 7, you look at the binary of that, you see that's 0, 1, 1, 1, 0, 0, and 1, 1, 1. Take the bitwise XOR of that. Also, if you want to take the bitwise XOR of multiple numbers, all I have to do is look at each digit and you see if there's an even or odd number. If there's an even number, then it's a 0. And if there's an odd number, then it's a 1. So you take the bitwise of all of that, you get 0, 0, 0. I don't know. It's a.
So 1357 would be like odd number 0, right?
So 1357. Odd number is
numbers
1.
are 0.
It would be 1111.
Even numbers are 0. So if you look at that, then the first digit, there's an even number of ones, that's a 0. Second one, there's 2 ones, that's a 0. Third one, there's 4 ones, that's an even number, that's a 0. So that's the bitwise XOR of 0, 0, 0. Therefore, what you want to do is you want to go second. And whatever you do, your opponent does, it'll always not be 0, 0, 0. Therefore, you can send them back to 0, 0, 0 over and over again. That's how you win this game. That's like the math underlying all this kind of stuff.
The key is try to get 0, 2, 3, 1.
I mean, 0, 2, 3, 1 is a winning position. 0, 3, 5, 6 is winning. You can check that using bitwise XOR, even though it looks really weird. 0, 3, 5, 7 is winning. 2, 4, 6 is winning, I believe. And then you can figure out all of these by doing the bitwise XOR. So you want to figure out which ones are winning by doing the bitwise XOR. Anyways, I've already gone well over time. So if you have any questions, feel free to ask me, like specifically about bitwise
Just
XOR.
copy and paste all the winning positions.
Nims. I mean, you should be able to figure out like how to calculate these out because I don't know. It's kind of useful, at least. Actually, not really, unless you want to beat your friends at this game. There's also some pretty useful computer science applications for bitwise XOR. But otherwise, if you have any questions, feel free to stick around. Otherwise, that's it for today's class. Next week will be